Now it's time for a little armchair philosophizing. I don't do any research, but I do a lot of reading. I've read a lot of Richard Dawkins and Stephen Jay Gould. There's a wonderful book by Kim Sterrenly called Dawkins versus Gould, Survival of the Fittest. It covers several of the things that these two great scientists and writers disagreed about. One of the notions was Stephen Jay Gould's theory of punctuated equilibrium. Niles Aldrich and Stephen Jay Gould came up with this idea that organisms stay pretty much the same over long periods of time and then change in relatively small geological time frames. A lot of time for us, but not a long time looking at the entire history of the world. This is not fully accepted. It's accepted much more than it used to be, but not fully. Dawkins accepted this as entirely possible, mentioned in several books. It was not emphasized much because Dawkins viewed some of the things that Gould wrote about as being the exception to the rule more than the rule itself. I don't think there was actually any real conflict between the notions of punctuated equilibrium and what some people would call traditional Darwinistic evolution, which would be regular change going slowly from one organism to another. There's a wonderful book called Endless Forms Most Beautiful by Sean Carroll. This book explains that there are small sections of DNA that can have large effects on the bodies of organisms. Natural selection works based on what can be determined in the natural environment, what you can tell about an organism. If you can't see it, you can't choose if you're a choosing organism. So, in times of crisis, you may change your choosing behaviors, but you can't choose about anything that you can't tell. So, organisms always evolve, their DNA always changes, but what's external may not necessarily change so much. So the traditional Darwinistic view that creatures are constantly changing may in fact be true, but the punctuated equilibrium concept may also be true. Small changes in DNA, the ones affecting how organisms appear, may be few and far between, even if the underlying DNA changes gradually and continuously. This is an important point. We're noticing mostly the differences in what's obvious when we're looking at fossils. We're not looking at changes in, say, hemoglobin over time. I think that may reconcile a couple things. I'm sure I'm not the only one with the idea, but this clarifies a few things to me. And hopefully it makes sense to someone else. Thanks.